right. Hello, everyone. Thank you for joining on time. So we waited a couple of minutes to let other people join, but I think we're good to start now. So welcome to today's webinar on guiding the SMEs on how to transform their business for a carbon neutral future. My name is Farzana Islam. I am the research engineer here in the WVU Pollution Prevention Program, and I will be your speaker for today. In this session, we will explore how small and medium enterprise can take practical steps towards achieving carbon neutrality, and I will walk you through a comprehensive framework that addresses the three critical aspects of this journey: technology, financial tools, and policy supports. Let's get started by outlining what we will cover in today's session. All right, we will start with some backgrounds on climate change and carbon emissions to understand why it's important to focus on these issues. Then we will explore the concept of carbon neutrality and what it means for businesses and industries. Following that, we will break down the key steps to reach carbon neutrality. Finally, we will introduce the comprehensive framework that integrates these key instruments, technology, finance, and policy that can help companies implement strategies to achieve carbon neutrality. By the end, you will have a clear roadmap and the tools to contribute to a sustainable, low-carbon future. So first, some background on climate change and carbon emissions. Looking at the data on CO2 and climate change, it's clear that carbon dioxide is the dominant contributor to US greenhouse gas emissions, accounting for 79.4% of all emissions. This is followed by methane at 11.5% and smaller amounts of nitrous oxide and other gases. The reality is that CO2 emissions from energy production, transportation, and industrial activities are driving climate change at a rapid pace. This context emphasizes the need for a swift and decisive action to reduce CO2 emission across sectors, especially in energy-intensive industries. As we move forward, focusing on CO2 reduction, which will play a critical role in limiting global warming. When we look at the top 5 emitters globally, the responsibility for 60% of GHG lies within just 5 players: China, the United States, India, the European Union, and Russia. This highlights a massive opportunity for these economies to lead the way in global carbon reduction efforts. Small and medium enterprises or businesses which are part of these major economies must also step up. Even though these companies might seem small compared to these large emitters, their collective impact on emissions is significant, and reducing their carbon footprint can greatly contribute to national and global climate targets. The target for USA emphasizes a bold commitment to reducing net greenhouse gas emissions by 50 to 52% below 2005's level by 2030. This ambitious goal aligns with the international efforts under Paris Agreement to limit global temperature rise. For businesses of all sizes, including SMEs, this means integrating carbon reduction strategies into operations is no longer optional but necessary step to stay ahead in an increasingly sustainably driven market. Now is the time to start or accelerate these efforts by incorporating carbon neutral technologies, financial incentives, and policy instruments that support emission reduction and sustainable growth. Now that we have established the gravity of the situation with CO2 emissions, the top global emitters, and ambitious target for the US, let's transition into understanding what carbon neutrality actually means, how it plays into this overall strategy. Carbon neutrality is about achieving a balance between emitting carbon and absorbing carbon from the atmosphere. This is a crucial concept because reaching net zero emissions is a core goal for both businesses and governments to combat climate change. Next, we'll dive into some important mechanism behind carbon neutrality to understand how exactly businesses and industries can reach this balance. So first, let's understand what carbon cycle is. The carbon cycle is a natural process where carbon circulates between the atmosphere, ocean, soil, and living organisms. Plants absorb CO2, animals consume plants, and when organisms decompose, carbon is released back into the environment. However, human activities such as burning fossil fuels and deforestation are disrupting this balance by adding more CO2 than natural system can absorb. Where do small business fit into this whole scenario? The SMEs may not have the emission footprint of larger corporations, but they collectively contribute significantly through energy consumption, transportation, and waste generation, and also through the manufacturing processes. While large corporations get much of the attention, SMEs make up to 90% of the businesses globally and are responsible for 60 to 70% of global carbon emission. Their collective impact through energy use, transportation, and waste reduction is substantial and making them a critical part of the solution to rebalancing the carbon cycle. Now, a carbon footprint is the total amount of greenhouse gases, primarily carbon dioxide, that are generated by our actions. This can include things like how much energy we use, the distances we travel, how much waste we produce. It is measured in terms of CO2 equivalent or CO2e to account for different gases like methane, nitrous oxide, and many other GHGs. Different industries have varying level of carbon footprints depending on their activities involved. Reducing a carbon footprint is a key to mitigating climate change. And now if you look at the image on the screen, it illustrates the breakdown of carbon emission across various sectors. For example, the largest contributions come from industry, which is 19.6%, electricity and heat, 18%, and agriculture, 15%. This diagram helps us visualize where the emissions are highest and highlights the area like transportation, buildings, and energy production. It is useful. It's a useful way to see where changes needs to happen and to reduce overall emissions. Okay, let's dive into the concept of scope 1, 2, and 3 emissions, which are the three categories business use to report their greenhouse gas emission. This image helps break it down clearly. Scope 1 emissions are direct emissions from sources owned or controlled by the company. These include things like fuel combustion in company vehicles or emissions from on-site facilities. For example, if you own a fleet of delivery trucks and the exhaust from the vehicles should be classified under Scope 1. Scope 2 emissions are indirect emissions from the generation of purchased electricity, steam, heating, and cooling. These are emissions that occur at a power plant but are associated with the electricity your business consumes. So if your office or factory is powered by electricity from the grid, those emissions fall under Scope 2. Scope 3 emissions are all other indirect emissions that occur in the value chain of the company. This includes both upstream and downstream emissions. These are usually the hardest to track, but can have the largest footprint. For example, if your business purchases raw material, the emissions from the production and transportation of those material would be Scope 3. It also includes emissions from the use of products you sell, waste disposal, business travel, and even employee commuting. It's especially important for small businesses to understand these categories, Scope 1, 2, and 3 emissions, because they often work as vendors or suppliers to large companies. Here's why this matters. Large corporations are increasingly setting ambitious sustainability goals, particularly around reducing their Scope 3 emissions. Since Scope 3 emissions encompass the entire value chain, this means emissions produced by their supplier, the small businesses, are directly part of those large companies' carbon footprint. So if you are a small business that supplies raw materials, components, or services to larger companies, you are part of their emissions profile. In fact, many big corporations or companies are now requiring their vendors to align with their sustainability goals. This trend is growing because large companies know that achieving their carbon neutrality targets depends heavily on reducing emissions across the entire supply chain, not just within their own operation. By adopting sustainable practices and moving towards carbon neutrality, small businesses can gain a competitive edge, and companies with low carbon footprint will be more attractive to large buyers looking to reduce their overall emissions. This can mean more opportunities for long-term contracts, partnership, and even financial incentives or subsidies offered by those large corporations. And it's a win-win situation. By positioning your business as a sustainable partner, you not only contribute to the global effort of reducing emissions, but also strengthen your market position and open doors to new business opportunities. Now let's talk about the core theory of carbon neutrality. In simple terms, carbon neutrality refers to achieving a balance between carbon dioxide emissions produced and the amount that is either removed or offset from the atmosphere. This means that for every ton of CO2 a company or individual generates, they need to remove an equivalent amount of equivalent amount from the atmosphere to reach net zero emissions. Now let's look at the image on the screen to better understand this process. On the left, you see emissions generated by the factory or any business activity. These are carbon emissions that come from burning fossil fuels, industrial process, or transportation. And on the right, you see that how these emissions are reduced or compensated through activities like increasing energy efficiency, using renewable energy, and even through carbon offsetting projects, such as tree planting or investing in carbon capture technology. The goal is to reduce emissions as much as possible first, and then offset remaining emissions that cannot be eliminated. When these two sides balance out, generated emissions and reduced offset emissions, we achieve carbon neutrality, symbolized by the zero on the right-hand side. So for businesses, this means carefully calculating their carbon footprint, reducing it through cleaner practices, and then compensating for the rest by supporting sustainable projects or purchasing carbon credits. So next, let's have a look at some practical steps small businesses can take to move towards carbon neutrality. To achieve carbon neutrality, businesses typically follow a structured process as illustrated in this diagram. This is a step-by-step approach that ensures we address emissions in the most efficient and impactful way, which includes calculating first and then avoid, reduce, and finally offset. So let's start by diving into the first step, the first critical step towards carbon neutrality, which is calculating your total carbon footprint. This means quantifying all the greenhouse gas emissions produced by your business activities across three scopes. The scope 1, 2, and 3 we have discussed in our earlier slides. So now to calculate the carbon footprint of any specific activity, we use this simple formula, which is the carbon footprint of the activity is equal to activity data times emission factor. So activity data refers to the amount of energy or resources used, like kilowatt hour of electricity, liters of fuel, kilometers traveled, or tons of material produced. Emission factor is the amount of CO2 equivalent generated per unit of activity. For example, how much CO2 is produced for every kilowatt hour of electricity consumed or every kilometer driven. By multiplying these two values, you can determine the emissions for any given activity. When you do this across all your activities in scope 1, 2, and 3, you get your company's total carbon footprint. And this calculation is the foundation for identifying where your biggest emissions come from and how to target them for reduction. Once we have calculated our carbon footprint, next step is to focus on avoiding emissions altogether. This involves designing system processes or choices that prevent emissions from being generated in the first place. And it can vary based on what kind of system you're using for the processes. However, here are some general best practices that can help you avoid emissions in daily business operations. The first one is using public transport or bicycles. Encouraging your employees to use public transport or bicycles for their commute can significantly reduce emission from individual vehicles. Promoting carpooling or shared company vehicles is another effective way to minimize transportation-related emissions, especially for businesses with frequent travel needs. Air travel is a significant source of carbon emission. By adopting to virtual meetings whenever possible, businesses can avoid these emissions associated with flights and long distance travel. Simple changes in the office like double-sided printing, switching to LED lighting, or using energy efficient appliances can help avoid unnecessary energy consumption. And finally, using materials like plastics, papers, and office supplies reduces the need for new resources and cuts down on the carbon emission associated with the production and disposal. After avoiding emissions as much as possible, the next step is to reduce the emissions that remain. And this also depends on what kind of process you have and what kind of technologies are relevant, and if there is an integration opportunity available for that, such factors. But then again, here are some general tips that can help you reduce the carbon emission, which includes implementing energy-saving measures, using hybrid or electric vehicles, shifting to renewable energy sources, reducing reliance on fossil fuels through biomass, increasing use of recyclable materials, opting for locally sourced items, and so on. However, for this avoid and reduce criteria, we are going to discuss in more in-depth technology sides in the later part of our presentation. All right, so once you have avoided and reduced as many emissions as possible, the final step towards carbon neutrality is to offset any remaining emissions. Offsetting is a way of balancing out the emissions that you can't eliminate by investing in projects that reduce or remove carbon dioxide from the atmosphere. So here's how carbon offsetting works. Companies invest in carbon offsetting projects such as reforestation, renewable energy initiatives like wind or solar farms, or methane capture projects from landfills or agriculture. For every ton of CO2 emissions that your company produces, you can purchase carbon credits through these projects. One carbon credit represents 1 ton of carbon dioxide reduced or removed from the atmosphere. By purchasing enough carbon credits to match your remaining emissions, you can effectively neutralize your carbon footprint, balancing out the emissions that couldn't be avoided or reduced. While offsetting is an important tool, it's considered the last resort after all other emission reduction strategies have been exhausted. The goal is always to avoid and reduce emissions first, and then use offsets to cover the remainder. All right, now that we have gone through 4 steps to achieve carbon neutrality, um, let's dive into the framework for process-wise implementation broken down step by step. It might seem a bit overwhelming at first, but it's actually a simple logical flow designed to guide you towards your goal. As you can see, the key points on the right side of the framework, technology instrument, financial instrument, and policy instruments form the backbone of the process. And in the following slides, we will explore each of these areas in more details. After that, we will revisit the entire framework to ensure a thorough process-level approach to decarbonization. Technology instruments are crucial for businesses aiming to achieve carbon neutrality. These are innovative tools and solutions that help reduce, capture, and offset greenhouse gas emissions. Today, we will have some ideas about these technologies for both current processes and new production pathways. Let's start by understanding the difference between these two. Current processes focus on improving or transforming existing production systems. These technologies are designed to make the systems we already have more sustainable. And examples include biomass, electrification, carbon capture and storage, low carbon dioxide, hydrogen, deep geothermal, and energy efficiency. New production pathways represent emerging or advanced methods of production that are fundamentally different from traditional processes. These are forward-looking innovations designed to not just reduce emissions, but revolutionize production itself. Examples include carbon capture and use, carbon recycling, process intensification, and circular economy. So we will briefly go through each of these technology to understand how that works and how it can help your business. So let's talk about biomass as renewable energy source. Biomass works by using organic materials such as wood, crop waste, animal byproducts as a fuel source. When burned, these materials release stored chemical energy from the sun, which is converted into heat, electricity, or biofuel. So how does it help? Biomass is a renewable source of energy, unlike fossil fuels. By shifting away from coal or natural gas and using biomass, companies can significantly lower their carbon emissions. It also provides an excellent use of waste materials, diverting them from landfills and creating a closed-loop energy systems. One great example comes from an energy assessment we conducted where we recommended a sawdust biomass boiler at a facility. This boiler will provide heating for the entire facility by using sawdust, which is a byproduct of their operations. Not only this will reduce the facility's electricity and natural gas consumption, but it will also repurpose waste materials that would have otherwise been discarded. Next, we have electrification, which is all about replacing fossil fuels, fuel-powered system with electric alternatives. For instance, instead of using natural gas to heat a building or run industrial processes, you should switch to electric heat pump or electric-powered machineries. By doing so, you can tap into cleaner electricity sources, especially if you use renewable energy like solar or wind. It drastically reduces a company's reliance on fossil fuels like natural gas and coal, which significantly lowers carbon emission. Additionally, many electric systems like heat pump are more energy efficient than their fossil fuel counterparts. Over the time, this leads to both environmental benefits and cost savings. Next, we have carbon capture and storage, which is also known by CCS, is a technology designed to capture CO2 emissions from industrial processes and energy production before they can reach the atmosphere. The process involves 3 key steps. Capture, CO2 is captured from large emission sources like power plants or factories, and then the captured CO2 is transported usually via pipelines to storage sites, And then at the last step, the CO2 is then stored deep underground in geological formation, preventing it from contributing to climate change. CCS can drastically reduce the carbon footprint of industries that are traditionally difficult to decarbonize, like cement, steel, or chemical manufacturing. By capturing the emissions directly at the source, it prevents large quantities of CO2 from being released into the atmosphere. Additionally, CCS can support industries that are not yet able to transition fully to renewable energy. It allows these businesses to continue operating while dramatically lowering their carbon emissions. And in some cases, the captured CO2 can even be repurposed for use in other industrial processes, adding further value. Next, we have low CO2 hydrogen, often referred as green hydrogen or blue hydrogen, which is produced with minimal or zero carbon emission. Green hydrogen is created by splitting water using renewable energy sources like wind or solar through a process called electrolysis, while blue hydrogen is produced from natural gas, but combined with carbon capture and storage to minimize emissions. This diagram illustrates the process of producing a blue hydrogen using methane as the primary feedstock through a reforming process powered by concentrated solar energy. Let's break it down step by step. Pretreatment process is where desulfurization happens. This first step involves removing sulfur compound from the methane. Desulfurization is a necessary step because sulfur can poison the catalyst used in later stages of hydrogen production. After this process, we have purified methane that can move into the next stage. Next, we have reforming process. In this step, in the reforming and shift reactor, methane reacts with the steam under high temperatures facilitated by concentrated solar energy. This step produces a mixture of gases, including hydrogen, carbon dioxide, and concentrated solar energy, which helps drive the reaction more efficiently and sustainably by reducing reliance on fossil fuel derived heat sources. Next, we have purification process of formate gas. After the reforming process, the gas mixture goes through PSA or pressure swing adsorption system, which purifies hydrogen. During this process, water and carbon dioxide are removed, leaving nearly pure hydrogen. And CO2 removal is crucial in this step because it ensures the hydrogen produced is clean and has a low carbon footprint. And hydrogen is a highly versatile fuel that can replace fossil fuels in energy-intensive industries. It can be used to power industrial processes that require high heat, which is difficult to electrify. Hydrogen is also an ideal energy carrier for long-term storage, helping businesses ensure a stable energy supply while reducing their carbon footprint. Next, we have deep geothermal energy works by accessing the Earth's natural heat stored deep beneath the surface. To do this, wells are drilled several kilometers into the ground to reach geothermal reservoirs. These reservoirs contain hot water and steam, which can then be used to generate electricity or provide direct heating for industrial processes. One of the key benefits of deep geothermal energy is its reliability. It provides continuous energy 24/7, unlike solar or wind, which depends on weather conditions. This makes it an excellent choice or solution for industries that need consistent, reliable energy to run their operations. Additionally, it's clean, renewable source of energy that can significantly reduce companies' reliance on fossil fuels. Next, we have energy efficiency, which is about optimizing how energy is used within your business by upgrading systems retrofitting older equipments, and improving day-to-day operational practices. It can be as simple as replacing old light bulbs with energy-efficient LEDs, or as comprehensive as installing a new, more efficient HVAC system. Energy efficiency upgrades aim to reduce the total energy consumption without compromising productivity. So during our energy assessments, we often identify opportunities for businesses to improve energy efficiency. Some of the most common recommendations include lighting replacement, HVAC upgrades, insulation and sealing, machinery retrofits. For example, during one of our assessments, we recommended a complete lighting retrofit, replacing outdated fixtures with energy-efficient LEDs, resulting in 70% reduction in electricity used for lighting alone. So next, we have one of our new production pathways technology, which is carbon capture and use. This is an advanced technology that not only captures CO2 emissions from industrial processes, but also converts them into useful products. Rather than simply storing the CO2 underground, as is done in CCS, CCU repurposes the CO2 for other industries. CO2 emissions are captured at the source, such as from power plants or manufacturing facilities, before they can be released into the atmosphere. The captured CO2 is then processed and transformed into valuable products like synthetic fuels, chemicals, or even building materials like concrete. By integrating CCU technologies into the operations, companies can significantly reduce their carbon emissions while creating new revenue stream for the byproducts. Next, we have carbon recycling, which is an innovative technology that captures CO2 emissions from industrial processes and chemically converts them into new raw materials. These recycled materials can then be reintegrated into the production cycle, reducing the need for virgin materials and closing the loop in carbon use. CO2 emissions are captured before they are released into the atmosphere. Through chemical processes, the captured CO2 is transformed into useful products like chemicals, plastics, or even fuels. These products can then be used within the same industry, effectively recycling the carbon that would otherwise contribute to climate change. So 6 major companies, including Toshiba, Energy Systems and Solutions corporations, Idemitsu Kosen Company and Limited, and All Nippon Airways have joined forces to explore a carbon recycling business model. The goal is to capture CO2 from industrial exhaust gases and convert it into sustainable aviation fuel, which is known as SAF, using the power to chemicals process. Next, we have process intensification, which is a powerful approach to optimize industrial production. It involves redesigning processes to make them more efficient, reducing the energy, space, and resources required to achieve the same output. This can be done by integrating several processes into one step or by using advanced technologies that streamline the production cycles. Next, we have circular economy, which is another new production pathways. And this is a production model focused on minimizing waste and maximizing resource reuse. Instead of the traditional linear model of take, make, and dispose, the circular economy emphasizes closing the loop by designing products and processes that keep resources in use for as long as possible. In the circular economy, products are designed for durability, reuse, and recyclability. At the end of the product's life, instead of being thrown away, its components can be disassembled, recycled, or repurposed into new products, creating a closed-loop system. And this reduces the need for new raw materials and limits environmental impact. Now that we have discussed the technological approaches to carbon neutrality, let's talk about the financial instruments that play an equally important role in driving the transition. It has two components, which we will discuss in the following slides. The first one is the pricing instrument, which includes carbon taxes, cap and trade systems, renewable energy certificates, and utility-based incentives. We're not going into very detail of this, but I encourage you to explore each of these points depending on what geographic location you are setting your business at. Next, we have the funding and investment instrument, which includes federal tax incentives, green bonds, USDA grants, IRA Act, Appalachian Regional Commissions, commission fundings, which are also great funding and investment instrument to support your decarbonizing effort. I want to mention particularly about USDA grants. Basically, we help businesses with these particular grants as we offer free or low-cost energy audits or energy assessments services from our team to prepare the energy assessment reports, which can be used to apply for these USDA grants or the USDA REAP grants, which can cover up to 50% of the implementation cost, and it also offers loans for that particular project as well. And our team also helps with the application process of USDA REAP, which is sometimes very overwhelming, very long application, and we can provide free assistance in applying for that particular grant. Next, we have policy instrument, which are essential tools that governments use to guide industries and individuals towards sustainable practices and achieving carbon neutrality. These instruments ensure the carbon reduction efforts are not just optional, but are driven by mandates, incentives, and standards. So this includes regulatory instrument. You will have access to different EPA regulations in their website. Then we have clean power plants, ISO 14001 standards, some West Virginia specific regulatory instrument as well, which is WV DEP air quality regulations, WV clean energy mandates, and energy efficiency resource standards, which are all a great policy instrument. You might find it useful before you go for the implementation of your decarbonization project. Next, we have several subsidy instruments. The federal tax incentives for renewable energy, clean energy investment programs, and subsidies for carbon capture projects, which is 45Q tax credit. So the 45Q tax credit focuses on reducing carbon emission by subsidizing carbon capture projects. This is especially important for industrial sectors aiming to lower their greenhouse gas outputs. Now that we have covered different instruments, technology, financial, and policy, let's walk through how this framework operates using the flowchart in this slide. The framework provides a step-by-step approach to incorporating decarbonization efforts into your business process. It begins with defining the process, identifying carbon-intensive step, and exploring available technologies for emission reduction. From there, we check for applicable financial or policy instrument that can support this implementation. Once the potential reduction in carbon emission is calculated, along with the economic viability, the business can determine the best approach to implement. This ensures the decarbonization aligns with the company's objectives and ensures the sustainability of the new adopted technology or policy. To make it more practical, we will now use an example from manufacturing industries, specifically metal production process that involves significant energy consumption. We will follow each step of the framework to show how this process can be decarbonized, incorporating real-world instrument and that supports emission reduction. So the first step is we define the process involved, or steps involved in the process. So first we identify the high energy processes involved. In this case, smelting process is energy intensive, involving the heating and extraction of metals. Step 2, which is identify carbon-intensive steps or processes. In this step, we assess the steps in smelting that lead to the highest emissions, which would typically include the combustion of fossil fuel or high electricity consumption during heating. In the next step, we identify available technologies for carbon reduction. We now look for technologies from the current processes or new production pathways categories. For this example, we can evaluate electrification, such as replacing fossil fuel-powered equipment with electric arc furnaces or biomass, where biomass energy replaces conventional fuel to reduce emissions. And in the next step, we evaluate the feasibility of integrating the selected technology into the current production process. For example, if we choose electrification in the previous step, by replacing fossil fuel-based furnace with an electric arc furnace, the next question would be to assess the compatibility of this new technology with the existing production line. We would check the potential modifications required, such as grid capacity or electric system updates, whether the existing infrastructure can support this new equipment. So if we choose biomass energy, we would evaluate whether the current fuel system in the production line can be converted to accept biomass. We might look into whether boilers can switch from coal or gas to biomass, and how that impacts emissions and energy efficiency. At this stage, careful considerations must be given to operational requirements, cost implications, and the technical requirements of integrating new systems into the existing workflow to ensure seamless transition toward carbon reduction. Now, let's consider what happens if the technology we initially selected does not work. Suppose after evaluating the chosen technology, we find that it is incompatible with the existing infrastructure or too costly to implement. In such cases, we don't abandon the carbon reduction effort. Instead, we revisit the previous step and select an alternative technology from the list of available options. For example, let's say we initially chose the switch from fossil fuel powered boiler to an electric arc furnace, but after further evaluation, we discover that the electric arc furnace requires a grid upgrade that the company cannot afford. In this case, we go back to the earlier step, consider another option such as biomass energy, and we might evaluate whether converting to the existing boiler to biomass could achieve the desired emission reduction without the high cost of grid upgrades. So this iterative process allows us to be flexible, ensuring that we eventually find a technology that aligns with both the carbon reduction goals and the business's practical and financial constraints. It's essential to continue this back and forth process until we find a suitable technology that can integrate it effectively. In this step, we would explore funding options. For instance, if the plant were based in West Virginia, we could leverage state-level subsidies or federal funding, say, for example, USDA REAP grants for installing energy-efficient electric arc furnaces. In the next step, we review any policy incentives such as carbon pricing initiatives or mandates that support the transition to electric or renewable energy powered processes. These policies help create a financial incentives for reducing emissions. And in the next step, or at this stage, we calculate the emissions reduction by switching to electrification or biomass. For example, using electric arc furnace could reduce emissions by up to 50% depending on the power source, um, um, uh, depending on the per source of carbon intensity. And here we compare the cost of the new technology and any financial assistance or incentives with the expected energy savings and reduction in emissions. Electrifications might offer significant long-term savings on energy costs, especially if renewable energy or renewable electricity is used. In the next step, based on the economic analysis and emission reductions, we can decide whether electrification or biomass would be more viable. Suppose the plant is already located in a region with access to renewable energy resources. In that case, electrification might provide the optimal balance of cost and carbon reduction. Another crucial factor in this decision-making step is the company's strategic goals and objectives. If the company has a clear commitment to becoming greener or reducing the carbon footprint as a part of its broader corporate strategy, they may still decide to proceed with the project, even if it presents challenges like higher upfront cost or the need for infrastructure upgrades. Let's say the company has a strategic goals of becoming carbon neutral by 2030. Even though transitioning from fossil fuel powered boiler to an electric arc furnace involves significant costs, the long-term benefits, like aligning with sustainability goals and potentially gaining a competitive advantage may justify the investment. In such cases, the strategic objective can outweigh short-term financial barriers, encouraging the company to move forward with the project despite the challenge. Once the decision is made, if it decides to go ahead with the project, the business can introduce the selected technology along with the supporting financial and policy instruments. And if the decision is made not to proceed with the chosen business case, then we can go back to the earlier step of identifying available technology. And from there, we repeat the evaluation process with another option until we find a solution that is both compatible with company's process and meets its objective. And lastly, we ensure the ongoing success of the new introduction. We monitored the results, tracking the reduction in emissions, and ensuring the business continues to meet its environmental objectives. This example demonstrates how framework can guide step-by-step decisions to decarbonize manufacturing processes while considering both environmental and financial impacts. So in conclusion, we have walked through the complete framework of achieving carbon neutrality. We explored various instrument, technology, financial, and policy that can help guide your efforts. Now it's time for action and assessing your processes, identifying where improvements can be made, and utilizing the instruments we have discussed will help you move closer to your sustainability goals. And by taking steps today, we all can contribute to carbon neutral future. Our team is committed to offering free industrial assessments, on-site training workshops, and various pollution prevention services to boost your efficiency and sustainability. Dr. Ashish Nimbarte, our principal investigator, guides the strategic direction of our projects. We have Dr. Chris Moore, our research associate. He contributes extensively for these energy audits and contributes his extensive expertise as well. And I'm Farzana Islam, the research engineer. If you have any questions or need support, please reach out to any one of us, and we would be happy to work with you and discuss the services we provide in details. These are the references listed here. I have these are the ones I have used to prepare this presentation, and I encourage you to explore them for more in-depth information. And thank you so much for your time and attention. We hope this webinar has provided you with some valuable insights into carbon neutrality and how it can benefit your organization. And thank you again. We look forward to working together towards a more sustainable future.